Mohammad Yusuf, and I'm gonna demonstrate our Milestone 5 and 6 project on behalf of my group. Our Milestone 5 and 6 project was a GCD version 2, and for this project we have to make two unit, like one is data path unit, another is control unit. So for the data path unit, it takes all the input and all the calculations and it gives data, but it depends on the control unit. Like when it's equal to or less than or greater than, it goes to the control unit and it gives feedback to the data path. When it is equal, then it shows the display. In the GCD 7 segment, we have 4 7 segment, so it shows there. This one is our data path unit. This one is the input unit where we give input of A and B, and here's the selector for selecting the input, and we have used cat3 from our Milestone 3 for displaying the display, like from 1 to 15. We can display from 1 to 15 through this cat3, and here's the output of our data path when it is less than, equal to, or greater than whatever. And this one is the input for the data path from the controller unit, like from the controller unit. So controller unit has the output 3 output, greater than, smaller than, and equal to, and also have input for clock, reset, and equal, small, greater than, and go. So the control unit can control the whole circuit through this button go. When a go is high, it runs the circuit, but when it is low, the circuit is turned off. So we can see here the data path gives data through greater than, equal to the control unit of equal to, small, and greater than. And the go, we have connected go to GCC, like we keep the control unit always on, and we control through the reset button. If the reset button is high, then it will turn on. If the reset button is low, then it will turn off. And we have given the data selector here, and the output of the controller come to the data path, and it shows the output. So for the control unit, when it is greater than, it's showing a greater than. When it is smaller than, it's showing smaller than. When it is equal, it's showing equal. But it can control through reset. If reset is low, there will be no output. If go is low, still there is no output if reset is high. So in our circuit, we keep go always on, and we just control the reset. Data path output, we have selected A and B, B001, A1110. Then selector, then C in, load, everything is high. And for debugging, we have used this data, but it's not working because our input is not connected yet, because this input will come from the controller unit. So the G out, H out is not working, and the equal and greater than is working, like this two is these things are working. The BCD also same, 1001 100 last 1100 last, because it's a connected. The output will go from here, and then it will go to the BCD if it get input here. So for the controller unit, for the final circuit, like this one, the final circuit, we have two input, one selector, one reset, and one clock, and also the G and H for debugging. So we give A like 1110, B001, then we give selector high, so it will go through G. Like H is 100, it's reverse, like 0 1 2 3, and B is from here, so it's reverse. And for G, it's going from 110 to until 100. So when it is equal, it gives the output, it gives a signal to the data path. And here's the BCD, you can see the first BCD is always 0 1 1 0 0 0 is for the B, and for the BCS it's changing rapidly and it ends up equal to the previous BCD. So that's for the data path, and we have also make ASM model like this one ASM. So this one is the state 1 when we here's the all in the input and output. So insert not output, all the inputs. So when go detects 1, like when go is high, it goes to next state. It check in the decision box that if A is less than B, if yes then it go back, if A is not less than B then it goes to here, if A is greater than B it go back and it come back. So in step 3 there is another decision button. If go is still high it remains in this state, if go is 0 it goes there. Video we can see like when we give the input, yeah, and we press the go button, it's working and it remain there until we don't turn off the go button and it go back to 15 and 11. So this is the purpose of this go button. If it's remain 1 into this loop F0 and it will go back to its initial state, the if. And thank you all for watching this video.